Hi, everyone. All right. I'm Hande McGinty. Thanks for being here. Thank you to the organizers for inviting us here. Today we're going to talk a little bit about the aging biomarkers ontology that we're building in collaboration with our industry partners, Biomarkers. And please excuse me if I cough in the middle. I recovered from my cold, but I left behind a cough. I am an assistant professor of computer science at the Kansas State University, but before joining Kansas State, I was at Ohio and working with the USDA. And prior to that, I had a long history in drug discovery, working with collaborative drug discovery, which used ontologies like bioassay ontology and drug target ontology that I built in their tools at the University of Miami during my PhD. So if you are here for a controversial discussion on what a biomarker is, you're unfortunately, I'm sorry to disappoint you today. We're not going to go into that because I am aware in the community what a biomarker is. Very much of a controversy, much more than you would hope or you would think that it will be. A biomarker's definition depends on a number of different people, a number of different perspectives, and depending on who you're talking to, what ontology you're looking at, you may see a phenotype in our ontology marked as a biomarker. We're not going to go over that. This is more of an application-oriented study. And it was because that we had a collaborative relationship with an actual company. So we wanted to answer their questions, and our approach was based on the questions and the problems that they brought us, and not so much in the knowledge representation sense for consensus building. So this is the biomarker definition that we had based on working with them. Unfortunately, biomarkers community within themselves are very much divided, and the literature is very crowded with misinformation and incomplete information and a lot of verbose definitions and descriptions of what a biomarker is. There are the omics biomarkers clan, I suppose. And then there are people who are really looking into biomarkers from an aging clock perspective. And then there are functional biomarker people who are on a different level and they look at a number of different things with a number of different samples and results that you need to go through, which makes life very hard when you're an ontology builder, ontology engineer, and you're trying to come to definitions and terms that can be reused and repurposed in different environments. And when you're trying to make use of the literature using LLMs, which was part of our approach, and we wanted to kind of see how that will work, if that can even work. So not only that, aging itself is a very complex problem, right? Aging is has many different factors that affect it. There are the epigenetic factors that affect aging, environmental factors, and genetic factors, and it's more and more considered that the different organs are aging differently and different tissues are aging differently. And based on that, what measurements and how those relationships among the biomarkers are forming and why they're forming, the causality behind it, is becoming much of an interest to the community. However, there's really not an ontology that is widely accepted that is in place. In the OBO Foundry, I know there are groups that are working and we're collaborating actively with building these ontologies, the biomarkers ontologies for use in clinical sense and also for aging. But currently the data sets are really sparse, and we've already discussed that the literature behind it is also very unorganized and really not standardized at all. So when we try to use machine learning approaches, this really poses a problem, because then you get a lot of noisy data, and based on that noise, the results are questionable at best, right? So we decided that we will take a small subset of the available biomarkers data, work with our collaborators at Eon Biomarkers, and really use them as our domain experts and use their domain expertise to help us define this in the small scale and see if we can scale it up and see how that exercise might result in. So we combined the data sets from NHANES data with select literature and our domain expertise and knowledge. And the first thing that we did on our, which I'm going to go in detail, but just to briefly go over it, the first exercise we had was to kind of get acquainted with the data using some statistical approaches to see how the data is looking in the NHANES data set and elsewhere, and see if there are any obvious correlations that we can find to kind of start looking into it and start with the ontological perspective looking into it. And we've already had a number of years in building ontologies, so we have some existing methodologies that we use for building these ontologies and knowledge graphs. So we use them to build an application ontology just to help our collaborators. And then we had some algorithmic approaches to see if the connections that we found elsewhere using the statistical approaches and via the ontology that we built can result or yield more connections if we were to look at it from some simple graphical algorithmic approaches. All right. So when building ontologies, I think building ontologies in a concordant manner is very important. So building ontologies that play well together harmoniously is very important when you are in a group like mine, when we're building lots of ontologies that need to work together and play well together. And with the advent of the LLMs, of course, we wanted to pepper it with LLMs to see how those results may change and what that might look like, and especially with all that noise in the literature, as we talked about. So when we look at the NHANES data set, the NHANES data set had individuals with their ages and their biomarker results. So based on the patient ID, we put them together and we annotate the data set with our domain knowledge, not our domain knowledge, but the domain knowledge of the EON biomarkers collaborators that we had. This is how it looked like. And then we applied statistical analysis just to see how the biomarkers, one biomarker based on its values, look like when it's filtered through other biomarkers. Say you're talking about your BMI, just to see how your BMI graph is changing when you filter it to your body fat biomarker, and see how where the fluctuations are, where the correlations are, if they're at all correlated. And we, based on that, we altered the data and created some categories. Again, really application oriented, not at all trying to get a consensus among the community. But like I said, we're actively collaborating with the community to see how we can help and see if our view of the biomarkers for this research may be used in theirs. So in our approach, one of the things that was important to us was how the FDA categorizes that biomarker, if there's an FDA categorization for that. Again, the other issue that we wanted to see was how invasive of a test is needed to reach to that biomarker. That's important in so many different ways. Talking to a commercial entity, cost is absolutely very important to them, right? If I can have a biomarker that I can test using urine, then why do I need a blood test? Or maybe looking at the urine is more expensive than looking at the blood. What is it? What are the cost benefits? Those are things that actually become very important when you're talking about commercial applications. Again, what is the sample source? And what are the different bodily fluids and entities that we're looking into, and what is the biomarker indicator of? Is it organ, system, disease? What is it for? So in the way that we build ontologies, we really want to build them for applications in mind, AI in mind, in my lab. For that's kind of how we've been focusing on things. I will check where I am in the time. Okay, and so we always build a database backend to go with things, and our database of choice is usually Neo4j for various reasons. Partly because we have other applications that we built that has Neo4j backend, so it just makes our lives easier when we want to integrate data, and put together the different modules that we built for other ontologies and other data sets, and really run applications faster. And I personally, in the way that I like to build ontologies, I don't think everything needs to be in the RDF form, and I think data can go between different data storage ways to help the application run faster, but that's a different discussion we can have over wine tonight. This is the olive methodology, as I was talking about. One of the things that we did, so that model, we just used our classic, let's talk to the domain expert, let's understand where they're coming from, here's how I understand your data, is it true, what do you think about it, kind of ontology building process. But with the advent of the LLMs, as we were discussing, we wanted to see if the literature can tell us something, and we can accelerate this process and see how the results may improve, if they would improve. So this is the manual process, and then this is very not so ready to scrutiny UI. I talked about this last year in some other detail, but the idea behind this is to see if we can load graphs or load abstracts or load any other text data and run it through the LLMs to see if we can get further information, enhance the graph, and see what may be the different connections that we can find. Unfortunately, as I was mentioning, because the biomarkers data set and biomarkers literature is so for lack of a better word, polluted, and there's so much noise, and there's so many different opinions and so many different levels of abstraction within the literature, it was very hard to come to a good result based on this approach. I think the only conclusion that I can give you that you can take home is that sometimes adding more data without a systematic approach is not what you want to do with the LLMs. And we're actively working on how we can improve our approach on this, but I don't have any results that's worth showing you at this moment with this approach. The other approach that we took is, I'm trying to see my time. Okay. Is excuse me. We use NetworkX to see if we can find more relationships among the biomarkers. If we were to find some links, if we were to try and predict some links, if we went down to 4 levels of depth and see if we could traverse on the graph to see what other connections that we can find. One thing that I will tell you that is when we were looking at, for example, if we were looking at BMI, and with a depth of force, looking at the associated with relationship, we'll just look and see what the neighbors are saying, and then based on that, we can identify if there are any new relationships among these data sets. One thing that we didn't look at that our domain experts kind of gave us as a feedback, which I thought was worthwhile and worthwhile in communication, is we didn't really look at the negative and the positive relationships among these things. And I think that will make a difference because you'll be not so surprised that we found a lot of correlations and a lot of relationships among these things. But I would suspect that some of these are positive and some of these are negative. And we actually, being computer scientists, didn't really think about this when we were first, going out to try and identify some of this. And then we used embeddings to see if we can embed what we know or what we encoded in the ontology, and then see if there were any other relationships and new correlations we could find among the aging biomarkers that we were looking at. And based on that, excuse me, approach, um, we found another 147 associations. Some of them are, obvious, right? BMI is obviously related with weight, but some of them, a little bit less obvious, perhaps. But the, vector embeddings gave us a different set of correlations, which needed further exploration and further scrutiny by our domain experts, our collaborators. In the works right now is to try and understand what is going on with the different correlations and how is the embeddings, underperforming versus the classic graph approaches, and why is that happening? Is it because we're not taking the right approach in our embeddings, or is it because we need further information from our domain experts? As I mentioned, we are actively collaborating with the OBO Foundry to see if we can actually get some consensus over what a biomarker is and how we can define it in a way that we, maybe most of us, not all of us, that does not happen, agree on, and how we can actually take the aging biomarkers research data and maybe help categorize it better for better analysis and faster integration in the research. And with that, nothing is ever complete without thanking our students. They're wonderful. Thank you again for listening, and I think I'm ready for questions.
Okay. Any questions for?
So you just mentioned that biomarker literature is polluted. What would be an area that you think is less polluted, like metabolism, or to do this Olive and making use of the LLMs for helping you build the ontologies?
Oh, you mean what would be a supplement to the biomarkers data set to help? No. What is not polluted? Is that the question?
I got a sense that because of all, you started off the presentation like biomarkers are hard and there's not a consensus.
Yeah.
And so that building this ontology has, I got the sense that building ontology around
Right.
this area has been difficult, and especially it seemed like you wanted to do
Yeah.
Olive and LLMs.
Right.
Okay, so is there an area, another use case besides the biomarkers and aging that maybe would have been more robust to your
Right.
ideas?
Yes, we actually have a study. We looked at the flavonoid contents of food and their correlation to cancer, which actually found some really nice results for us, which I presented here last year. So yes, there are use cases that Olive worked really nicely, helped us find some new things that were exciting to us, and we integrated that. But as Chris was talking about yesterday, and I think I mentioned it here last year as well, evaluation of these results becomes a huge problem. And there are no benchmarks, there are no, gold standards. I don't think there are even established workflows that we kind of agreed on or followed to consistently check of one another's work on that. And I think that's very, very important, because I think all of us can now build ontologies using LLMs. That was a 2-year ago problem that we didn't know how to do it. We do it now. But how do we evaluate how much value they bring in and how well they are, I think remains a problem. So
Hello. So thanks for the talk. And I'm just curious of what these biomarkers are. Genes, proteins, what are these?
these are functional biomarkers. Good question. Yeah.
What is it?
They are functional biomarkers. They call it functional biomarkers. They're things that you would get in a blood test, urine test. These are based on the survey data that CDC performs, I suppose, every year on American people. You can go, it's called NHANES data set.
So based on what these biomarkers are being classified? Is it whatever I saw on the slides? Is it like based on the weight, these categories? Because if we take gene ontology,
Right.
there are three things: molecular function, biological process. I'm asking in that way, what are the categories in which these biomarkers are classified?
Great question. Those are they call it omics state biomarkers, and omics biomarkers were not considered at all in this data set. But I agree that I think they need to be considered and they need to be connected. But that remains that's part of the problem. I think is that biomarker community in itself is very divided. But yeah.
All right, we are out of time for questions. Thank you very much.